हाय एवरीवन, इस वीडियो में हम बात करने वाले हैं एल्डोल कंडेंसेशन की। बेसिकली एल्डोल कंडेंसेशन में क्या होता है, एल्डिहाइड या कीटोन आपस में कंडेंसेशन रिएक्शन करके हमें एल्डोल देते हैं। बेसिकली जो नेम है एल्डोल, ये कहाँ से डिराइव होता है? ये डिराइव होता है फ्रॉम एल्डिहाइड एंड फ्रॉम अल्कोहल। मीन्स ये एक ऐसा कंपाउंड है जिसमें एल्डिहाइडिक ग्रुप भी प्रेजेंट होता है और अल्कोहलिक ग्रुप भी प्रेजेंट होता है। अगर हम इस रिएक्शन के लिए नेसेसरी कंडीशंस देखें तो नेसेसरी कंडीशन है प्रेजेंस ऑफ अल्फा हाइड्रोजन। व्हाट डू वी मीन बाय अल्फा हाइड्रोजन? नाउ कम टू दिस, सपोज दिस इज आवर कार्बोनिल ग्रुप, इट मे बी ईदर कीटोन और अ एल्डिहाइड, राइट। अब इसके पास में जो कार्बन होता है, इसके एडजेसेंट जो कार्बन होता है, दिस कार्बन इज कॉल्ड अल्फा कार्बन एंड द प्रोटॉन्स ओवर दिस कार्बन आर कॉल्ड अल्फा हाइड्रोजन, right? The hydrogen at this carbon are called alpha hydrogen, and we know very well that these hydrogens are acidic in nature. Why they are acidic? Because let us consider a base is added and a proton is abstracted. What do we get? We will get CH2 minus C double bond O X, X representing either aldehydic or ketonic group. Now come to this, this anion is stabilized by resonance on this carbonyl group, right? So because of this resonance stabilized nature of this carbon ion, we can say that these protons are acidic in nature. All right, so come to our reaction. Basically, if we used to consider some examples, we can take example of ethanol. In ethanol, we know very well that this one is alpha hydrogen, right? This one is alpha carbon, and there are hydrogens at this carbon. Okay. Similarly, we have two molecules of ethanol. Okay. What would happen? We will get this product. This product is basically 1, 2, 3 3-hydroxybutanol. 3-hydroxybutanol is the product. It is also called aldol. Why? Because it is having both aldehydic and alcoholic functional groups. Come to next example. Next example, we can consider propanol. In propanol, we can say that alpha hydrogens are present. 2 alpha hydrogens are present at this carbon. Come to this, these two are alpha hydrogen, and therefore because of the presence of alpha hydrogen, we can say that propanol is able to show aldol condensation. Okay, and we will get 1, 2, 3 3-hydroxy 1, 2, 3, 4, 5 3-hydroxy pentanol. This is pentanol because of 5 carbon, and the methyl group is present at 2 position. We can say that 3-hydroxy 2-methyl pentanol. Come to next example is of propanone. In propanone, we have 6 alpha hydrogens. Both of the carbon are alpha carbon, and there are hydrogens, so we can say that there are plenty of hydrogens, alpha hydrogens. So we can get over here like this compound is also able to show a aldol condensation, and we will get this product 1, 2, 3, 4. This is a 4-hydroxy ketone. Now come to discuss its mechanism. This step has been discussed. So the first step over here is abstraction of proton. Step 1 is abstraction of proton. Let us consider if we are having example of ethanol. We will have H, CH2, C double bond O, H, right? And we are having a dilute base. For this reaction, a dilute base is sufficient. So if we are having sodium hydroxide, what would happen? It will abstract a proton from here, and it will give CH2 minus, C double bond O, and H. All right. So we can say that at this step our nucleophile has been generated. This will behave as a nucleophile, and this is our enolate ion. So this point is also you should have to remember that in aldol condensation, enolate ion behave as a nucleophile. This is an important step, right? Next one is step 2. Next one is our step 2. In step 2, we are having this enolate ion. Step 2 is basically a condensation step. It's a condensation step. What do we mean by condensation? Condensation is a reaction of two same or different molecules with the removal of a simple molecule like ammonia, or you can say hydrogen chloride, or water, or alcohol. This is called condensation. So what would happen over here? It will attack at carbonyl carbon because it's a nucleophile, and carbonyl can be easily attacked by nucleophiles. What would happen over here? We will get CH3, C. As soon as enolate ion will attack at carbonyl carbon, what would happen? Carbon will transfer the electrons of double bond to oxygen atom. We will have a negative charge at oxygen atom, CH2, C double bond O, and H. So over here we are having a negative charge. What would happen? This negative charge, it will try to neutralize this charge. What would happen? In medium we have water. It will take proton from water, fine. So this is our 1, 2, 3 3-hydroxybutanol. This is our 3-hydroxybutanol. All right, or you can also call it as beta hydroxybutanol. Fine. One more step can be done over here. This is not a part of actually aldol condensation, but it may occur. That is dehydration. We know very well that alcohols can be dehydrated easily. So as soon as we heat this compound, what would happen? We will get CH3, CH double bond CH, C double bond O, and H. That is alpha beta unsaturated aldehyde. We will obtain alpha beta unsaturated aldehyde. So this is all about the mechanism of aldol condensation. We have 3 steps over here. In first step, we can say that first step is generation of nucleophile, or you can say generation of enolate ion. How it will be generated? By removing its alpha hydrogen. Next one is attack of nucleophile over carbonyl carbon. Further, we can say that abstraction of proton from water to neutralize this compound, and ultimately we will get our hydroxy compound, or you can say aldol. This is called aldol because of both functional group are present, that is aldehyde and alcohol. Therefore it is called as aldol. Further, if we use to heat this compound, we will get alpha beta unsaturated aldehyde, and if we are considering a ketone, we will get alpha beta unsaturated ketones. That's all about aldol condensation, and this reaction is also named as self aldol condensation because in all the example we can say that both the reactants that are getting condensed are same. That is why it is known as self aldol condensation. Thank you so much for watching.